Okay, good afternoon, you guys. We are learning this. I know it looks like L'Hopital's. It's a L'Hopital's rule. L'Hopital's rule is to help with finding limits. And so we'll just jump right in. So it's a way to find the limit when you get an indeterminate. So just remember that an indeterminate is 0 over 0 or infinity over infinity, or it can also be 0 times infinity, but we do need it in this form that you see here. So 0 over 0 or infinity over infinity. So if you think way back to when we talked about limits, this did happen a lot. We'd get these and we didn't really know what to do. So this is a way to help us with that. The definition says that if f of c equals g of c, which equals 0. So if you have two functions where they both equal 0 and f of c exists and f prime of c exists and g prime of c does not equal 0, then this statement is true. So the limit as x approaches c, where c is just a number, of f of x over g of x. This could be anything. F of x could equal a number, it could equal a polynomial, it could equal a trig function, same with g of x. So a function over a function, that's all that's saying. The limit is equal to their derivative. So that's not using quotient rule, it's taking the derivative of each piece, so the top and the bottom. And then it's also true if both functions equal infinity, so you would get infinity. So this is saying f of x equals 0, or f of c equals 0, g of c equals 0. So right here you would get 0 over 0, take the derivative, you'll get an actual number. Same thing down here. If they both equal infinity and f prime of c and g prime of c exist, and g prime is the derivative of g is not 0, then this is also true. So essentially what it's saying is if when you take the limit, when you plug in that c value, and if you get 0 over 0 or infinity over infinity, then you can take the derivative and replug in the value and you'll get your answer. Let's do some practice problems. And again, make sure you're taking the derivative of the top and the derivative of the bottom. So C, find the limit as x approaches 0 of sine x over x. So as you can see, if we just plug in 0, we get 0 over 0, which is an indeterminate. First of all, you can't have 0 on the bottom no matter what. And then when you get 0 over 0, that's what it's called an indeterminate. So what you need to do is take the derivative of the top and the bottom. So go ahead and do that. Take the derivative of sine x, take the derivative of x. Remember, you are not using quotient rule, they are individual functions. Excuse me. So when you take the derivative of sine x is cosine x, the derivative of x is 1. So now we're taking the limit as x approaches 0 right here of cosine x over 1. So that's what we're going to find the limit of. Can I plug 0 into this and not get an indeterminate? Yes. So when I plug 0 in for cosine x, cosine of 0 is 1. Go back to your unit circle over 1, which just is 1. Remember, you can always pause this. Okay, example 2, find the limit as x approaches 0. We have 2x minus sine x over x. Again, if we just start by putting 0 in, we get 0 over 0, which is an indeterminate, which we can't have. However, remember that limits also cannot be undefined. They might not exist, but they cannot be undefined. So getting 0 on the bottom doesn't mean you're done. It means you have more work to do, essentially, whether that be factoring, using L'Hopital's rule, whatever it might be. So obviously everything right now will be L'Hopital's rule. So we need to take the derivative of 2x minus sine x, that individual piece, and then of x. So what is the derivative of 2x minus sine x? Well, the derivative of 2x is just 2, the derivative of sine x is still cosine x, so we get 2 minus cosine x over the derivative of x is 1. So now you're taking the limit as x approaches 0 of 2 minus cosine x over 1. Now we can plug in our 0, and that's going to give us 1 over 1, which is 1, because 2 minus cosine of 0 is still just 1. 2 minus 1 is 1. And then 1 you have nothing to plug into. So this really isn't too difficult. It does not get really any more difficult either. You're just taking the derivative of each individual piece. The things to remember is that you can't do it if you don't have an indeterminate function, and not to use quotient rule. I have a few more examples. So find the limit as x approaches 0 of 4 plus the radical of 4 plus x minus 2 over 2x. I'm sorry, you guys, I have a cold. So go ahead. You can bet that when you plug it in, you will get 0 over 0. So go ahead and take a minute, pause it if you need to find the derivative of the top piece and the bottom piece. Remember, again, you are not doing quotient rule. It's the top alone and the bottom alone. However, on the top, you will have to use chain rule with that 4 plus x, the radical of 4 plus x. Remember, you can change that to a 1/2. Okay, so when you take the derivative, you get 1 over 2 times the radical 4 plus x over 2. If I plug 0 into this, I'm going to get 1 over 8. Okay, because I get 1 over 2 times 2, which is 4, and then all that over 2, which is 8. So again, always pause this if you need to. This one is similar, except for we've added this extra piece on the end, minus x over 4, and this x squared. So again, you're going to start by plugging in 0. We see it gives us 0 right away. So take the derivative of the top and the bottom. Keep in mind you've already done the derivative of this 4 plus x minus 2 portion, so you just have to use what we have up here and tack on the derivative of x over 4. Remember, x over 4 is the same as 1/4 x. Okay, so when we get the derivative. However, what happens when you plug 0 in? Go ahead and pause this and try and plug 0 in and see what you get still on the top and the bottom. When you do that, you should still be getting 0 over 0. So what can we do? You can actually take the derivative again. L'Hopital's rule says you can do it as many times as you need until you stop getting 0 over 0 or infinity over infinity. So we're going to take the derivative again. So now you're taking the derivative of this piece over here, and that's going to give us this. Make sure you actually work that out so you know how to do it. Now plug in 0. When you do that, you should get negative 1 over 128. So again, this just goes back to our start. It goes back to derivatives and all of that. Okay, one more example. So as x approaches infinity, we have 5x minus 8 over 3x plus 1. So this is actually something we already know how to do. When I plug in infinity, I get infinity over infinity, because remember, this 8 and this 1 are really not important. However, which is an indeterminate. However, I can take the derivative of both sides, of both the top and the bottom, which would leave me with 5 over 3, which is the limit is 5 over 3. This is something you know though. You know that when you're going to infinity and you have the same x, the same polynomial, that you can just cancel them off and that's what you're left with. So some cases you don't need to use L'Hopital's rule if you already know another shortcut to it. It's just showing you that that's why it works. Okay, last example. So this says find the limit as x approaches 0 from the right. Now that doesn't matter too much for us because remember it's as x is approaching, so it's getting a little closer and closer and closer and closer, so we still use 0 to test it. We're still using 0 to test it. However, where it does matter, so if I plug 0 into x, I get 0. If I plug 0 into cotangent, because it's approaching, we are, cotangent, remember, is x over y, not y over x. So I'm taking 1 over a number that's getting closer and closer and closer to 0. So it's like taking 1 and dividing it by 0.000001, or 1 and dividing it by just really, really small numbers, which gives us, I don't know if you can see, really big numbers. So 1 divided by 0.00001 equals really big numbers. So it's still going to 0 times infinity, which is 0. And this is an indeterminate, but it's not in the form that we need to use our rule. So how can I rewrite my original problem. X times cotangent x. What is cotangent x the same as? So think about how can you rewrite your original problem so we have it in a form that works for us, so we can use L'Hopital's rule. Because remember, L'Hopital's rule says you have two functions, f of x over g of x. It must be over, it can't be multiplied together. So we know that cotangent x is the same as 1 over tangent x. So if we rewrite this, we still are going to get the same answer. That's still going to give me an indeterminate where I'm going to have 0 over infinity. So now we're going to take the derivative. What is the derivative of x? It's 1. What's the derivative of tangent x? Secant squared x. When I plug in to this, I get 1. Because secant squared of 0 is just 1. So there's that. The next page has classwork problems. Please email me if you have questions. I will post this PowerPoint on Schoology as well. Basically, as I've been saying, you take the derivative of both the top and bottom. In some cases, you may need to rewrite it so you have a fraction. So you can take the derivative of the top and bottom, and then find the limit by plugging in your value or whatever you're left with. Email me if you have questions, message me on Schoology, whatever you need. I hope you guys are enjoying your days off, and I will see you all on Monday morning. Brandon and Aaron, you are on for snacks. Okay, bye.